All right, Algebra 2 students, you got a midterm coming up. Let's see if we can fit an entire quarter in about 20 minutes. So we started off reviewing forms of lines. If you'll remember, we have the standard form of a line, ax plus by equals c. Slope-intercept is y equals mx plus b, and point slope is y minus y1 equals m times x minus x1. So what's all this stuff stand for? A, B, and C by themselves don't really mean anything. Standard form is good for graphing, and then we'd use a lot of word problems, but those things aren't the slope, they're not the y-intercept by themselves. You have to convert it to slope-intercept normally if you want to learn that stuff. M in slope-intercept form is the slope, and B in this problem is the y-intercept. It's called slope-intercept form because mathematicians are super creative when they name stuff. It needs a slope and an intercept. Slope-intercept. It's not rocket surgery. Point slope requires a point, x1, y1, x1, y1, and a slope. M is still the slope. So you can plug in any point. Point slope is cool because it doesn't have to be the specific point on the y-axis. It can be any xy pair. So you can write infinitely many point slope equations for a line, which is what makes it so handy. That's why I'm going to use point slope for these problems. It says write the equation of a line that is parallel to this line and passes through the points negative 2, 5. So I always start with point slope. You can do it this way or not, but parallel to means it has the same slope. And then you have to know this is in slope-intercept, its slope is negative 2. So the slope that I'm going to use that's parallel is negative 2, and it passes through that point, so that's my x1, y1. So if I'm allowed to write it in point slope, y minus the y-coordinate is 5. The slope is negative 2. X minus negative 2, I'm going to write as x plus 2. That is sufficient as an answer. But if it says, if it's multiple choice and your answers are all in slope-intercept, you might need to convert it. So to do that, negative 2x minus 4, add 5 to both sides, negative 4 plus 5 is 1. So you could convert it, or if it was like on Khan Academy, just leave it in point slope. Same idea here. Perpendicular, so perpendicular slope is the opposite reciprocal. The opposite reciprocal of 3 is negative 1/3. So y minus negative 4 is y plus 4 equals negative 1/3, x minus 5, and I'm just going to leave it in point slope. If you have to convert it, distribute, subtract 4. That's lines. Graphing linear systems. So these are linear inequalities. You could probably just use Desmos or a graphing calculator, but these are both in slope-intercept, so I'll graph them. They're easy. Start at 12. The y-intercept here is 12, and you go down 2 over 1, down 2 over 1, down 2 over 1. Do that a bunch. The more intersection points you have, or potential intersection points, the better, really. So it's going to look like that. And you also need to remember that if it is a less than or equal to, it is a solid line, so stays solid. And when it's less than, you're just going to shade below. So I'm going to shade down, but I'm not actually going to color it in because I'm going to have to find the overlap. So I'm shading below it, or it's kind of to the left, but think of it more as down. This other line I'm going to graph, so I did that one in yellow. I'll graph this one in green. I'm going to start at the y-intercept 3, and I'm going to go up 1 over 1 because the slope is 1. So up 1 over 1, up 1 over 1. And in this, since it's a greater than and not a greater than or equal to, it actually needs to be a dashed line. So when I draw this, that's a solid line. I need to make it dashed. Now it's a dashed line. And again, since it's greater than, I want to shade above this time, so I'm shading up. And what I'm really concerned about in this problem is the overlap. That's the solution set. So the overlap, you can see, is above the green line and to the left of the yellow line. This is the set of solutions to this system of inequalities. So if it says identify 3 solutions, you just need to give me 3 ordered pairs that are in the shaded region. So I like to be a little fancy here. Let's pick one right there. So that's 1, 7. 1, 7 is a solution. If I plug 1, 7, it will make a true statement. How about over here? Negative 10, 0. That's a solution. Something in the middle, what's that? Negative 7, 6. That's a solution. If I plug these ordered pairs in to both of these equations, they will make true statements, both of these inequalities. If I pick a point from somewhere else, it won't work in both, so it's not considered a solution. Solving systems. Oh, 3-variable system. This could take a while. I like to label these. Let's do 1, 2, 3. Let's call this my first equation, second equation, and third equation. The name of the game is you have to combine two equations and eliminate a variable, but you have to do that two different ways. If you can find easy variables that'll cancel out, do that. So I'm looking at these two because right now those x's will cancel out. I'm going to take lines 2 and line 3 and I'm going to combine those and I'm going to create a new equation. So if I add these two equations together, x's cancel out, 5 plus 3 is 8, and 12 minus 2 is 10, 73 plus 1 is 74. Now I have an equation with two variables. Well, that's not going to help me by itself. I'll call that my A equation. I need to find another two equations that I can combine that will eliminate x. I committed to x when I eliminated the first time. So I think the top two would work. I'm going to take line 1. Line 1's fine by itself, but I'm going to multiply this because if I add those together, that's going to be 2. I wish that was a -3. I can't just make one of these numbers -3, so I need to triple this line. So 3 times line 2 is -3x plus 15y plus 36z, and 3 times 73 is 210 and 9, 219. Okay, distributive property. X's go away. 15 minus 2 is 13y, 36 plus 4 is 40z, and 219 plus 20 is 239. I'm going to call that my line B equation. Notice I have two variables and two unknowns, so I can combine these two equations to eliminate a variable, and then the dominoes start to fall. How can I do that? Let's see. 8 and 13, 8 doesn't go into 13. 10 goes into 40, so I'm going to do -4 times my A equation, which would be -32y minus 40z equals 280 and 16, -296. Line B, 13y plus 40z equals 239. Now I can add these two equations together. Z's cancel out. -32 and +13 make -19y, and on the right side, 239 minus 296 is -57. I can solve for y. If I divide both sides by -19, -57 divided by -19 is +3. Y is 3. Let the games begin. We just got to work back up now. So if I plug that in, what looks easy? That looks easy. 8 times 3 plus 10z equals 74. 24 plus 10z equals 74. Subtract 24 on both sides. 74 minus 24 is 50. And then divide by 10. Z equals 5. Okay, we got two of them. Now we got to go back up here and pick one to solve for x. That's a 1x, so I'm doing that one. So I'm going to copy that so I don't have to keep scrolling. This guy, come down here. Okay, x plus 3y minus 2z, but I know what y is and I know what z is. X plus 3y minus 2z. I'm just plugging in my y and my z values. X plus 9 minus 10 equals 1. X minus 1 equals 1. X equals 2. As an ordered triple, I'd write my answer as XYZ 2, 3, 5. Now, on a multiple choice test, you are crazy to do all that. What you can do instead is you can work backwards. You can take these answers and you can plug them in and verify that they work. So what I mean is, if I think this works, I can plug it in. 3 times 2 minus 2 times 3 plus 4 times 5. If I get 20, I know it works in the first one. It does. The opposite of 2 plus 5 times 3 plus 12 times 5. Does that equal 73? Uh-oh. What did I do? I typed something in. Oh, I forgot. Okay, opposite of 2. Try it again. Plus 5 times 3 plus 4 times 5. Does that equal 73? 33. What did I do wrong? Oh, I can't use my calculator at all. I'm struggling. Plus 5 times y is 3. I copied the problem right. Plus 12z, 12 times 5. Does this equal 73? Yes, finally, good. Okay, and then I'll try it one more time. 2 plus 3y minus 2 times z is 5. Make sure you type it in correctly, hopefully be 1. Yes, it worked in all three. Work backwards for these problems if it's multiple choice, otherwise you're going to be here all day. Okay, linear programming. Kings Island is trying to figure out how to maximize their profit. They get $4 for every keychain and $8 for every snow globe. Okay. Keychains are X, and so that's my keychain axis, and this is my snow globe axis, SG. Let's do $4 profit for every keychain that you sell and $8 profit for every snow globe that you sell. That's the objective function. We are going to maximize the objective function by testing the vertices of the feasible region. Nice. Okay. The feasible region is the overlap. That's right here in purple. You see what I'm boxing in here? This is the feasible region. But there's a cool property that says you don't need to test all those points, you just need to test the vertices. I labeled the vertices for you. I'm going to plug those into the objective function and see who the winner is. So 4 times 0 plus 8 times 0, shockingly, that is 0. 4 times 0 plus 8 times 2, I'm plugging in this one now, 0 plus 16 is 16. 4 times, what's that, 2, 6, 4 times 2 plus 8 times 6, 8 and 48 make 56. 4 times 8 plus 8 times 0 is 32. So how does Kings Island maximize their profit? Well, they can make $0 by doing nothing. They can make $16, they can make $56, or they can make $32. The way you should phrase your answer is you should say, they can maximize their profit of $56 by selling 2 keychains and 2 keychains and 6 snow globes, or whatever ratio. If they do 2,000 and 6,000, that's still the best. So 2, 6 is the best ordered pair. They will make $56 profit. Quadratics. So that was the first part of the semester. Now we're in the quadratics. So I'm going to go through all the forms of a quadratic. Standard form of a quadratic is ax squared plus bx plus c. Now, A tells you whether the quadratic opens up or down. If it's positive, it opens up. If it's negative, it opens down. And ignore the sign for a minute. And if the absolute value is big, then it is going to be more narrow. So it gets skinnier as it gets bigger. It gets wider as it's smaller. So a small a value, like 1/2, would be a little bit wider if a was 1/2. And if a was like 10, then it would be really steep on the sides, so narrow. So that's what A tells you. B doesn't really tell you anything by itself. C is the Y-intercept. If you plug in 0, these terms cancel out and you get the Y-intercept. Now, it is worth noting that when you have a parabola, the way I remember this is if A and B are the same, so let me take this parabola here. Well, I can't do the endpoints. That's fine. If A and B are the same, the axis of symmetry moves to the left. So like right now, I know that A and B are the same. So A is positive, that means B is positive. Over here, A and B are different. If A is positive here, B would be negative. So you can kind of use B as long as you know A. If A and B are the same, the axis of symmetry is left, so it could look like that. Or here, A and B are both negative, like that. A is negative because it opens down. If we want to find the axis of symmetry from standard form, we use the formula negative b, or the opposite of b over 2a. So in this problem, the opposite of b is negative 8 over 2a. Make sure you type this in correctly. Negative 8 over negative 4 is positive 2. The axis of symmetry is x equals 2. The vertex, to find the vertex by hand, you plug in the axis of symmetry. So everywhere you see an x, you're going to plug in a 2. And when you do that, you get negative 8 plus 16 minus 3 is 5. So the vertex is at 2, 5. I'll come back to the x-intercepts. The y-intercept is at the end. When you plug in 0, you get negative 3. Now the x-intercepts, you have to do the quadratic formula. So the opposite of b plus or minus b squared minus 4ac all over 2a. I do the discriminant first. When I do these problems, where's my calculator? Come on, calculator, what's your deal? You gonna work? There we go. So the discriminant is b squared minus 4ac. 8 squared minus 4ac. Type that in, you get 40. So the discriminant is 40. That part of it is 40. The opposite of b, negative 8, plus or minus radical 40 over 2a. 2 times negative 2 is negative 4. I'm going to simplify 40. That's 2, 2, 2, 5. If you factor 40, it's 8 times 5. 8 is 222, so this is 2 radical 10. The square root of 4 is 2. So negative 8 plus or minus 2 radical 10 over negative 4, and I can simplify that by distributing the negative 1/4. Negative 8 divided by negative 4 is 2, plus or minus 2 over 4 is 1/2 radical 10. So 2 plus or minus 1/2 radical 10 are the x-intercepts. That's two x-intercepts. They're both very terrible decimals. 2 plus 0.5 radical 10. 3.5811, but I want the exact answer here. So to do that, you have to simplify the radical. That's standard form. What about completing the square? So completing the square, if you draw a picture, which I like to draw pictures for completing the square, this helps me. So I'll draw a square. That looks pretty squarish. And I'm going to say, okay, I want to take this polynomial and write it as a square. To do that, I would take half of 6, which is 3. And then I have a square now that's x plus 3 times x plus 3. If I asked you what the area of that corner was, you'd say, well, it's 3 by 3, so it's 9. I'm going to complete the square by adding 9 to both sides. The way to think about the formula is you do b over 2 and you square it. So 6, which just looks like my b, 6 over 2 squared is 3, 3 squared is 9. So here I would make 9 c, and I would have a perfect square, and I could factor it to x plus 3 squared then. Same thing here. If I take my little picture and I say, okay, what's half of 10? You'd say x plus 5 by x plus 5. The corner would be 25, so I'd have to make that at 25. That's called completing the square. We're going to use that to solve, I think, right here. Yeah, there we go. Okay, so to solve by completing the square, the first thing you want to do is set y equal to 0. And then move your c term over, so subtract 3. Negative 3 plus something equals x squared plus 4x plus something. I know I'm going to need to put something in there when I complete the square, so I'm going to just cut this, next page, come on, paste. Okay, so I'm going to complete the square on the right side the same way I did there. X plus half of 4 is 2, and that means the corner here, it's x plus 2 by x plus 2, the corner is 4. If I want this to be a perfect square, I need to add 4, but you can't add 4 to one side, you need to add 4 to both sides. On the left side, 4 minus 3 is 1. On the right side, that is factorable, but I don't actually need to factor it because the dimensions are x plus 2 and x plus 2, that's x plus 2 squared. If I want to isolate x now, I'm going to square root both sides because that's how you undo square rooting, and the square root of 1 is plus or minus 1. When you take the square root of both sides, you need to remember plus or minus. The square root of the quantity squared is the just the term that's being squared, x plus 2. Last thing, to get x by itself, subtract 2. So negative 2 plus or minus 1 equals x. Well, those can be simplified. Negative 2 plus 1 is negative 1, and negative 2 minus 1 is negative 3. So my answers are x equals negative 1 and x equals negative 3. That's solving by completing the square. Bothers me. There we go. Solve using square roots. So you want to isolate the squared term. Do not square root yet. First, divide by 2. X squared equals negative 12. Once you have the squared term by itself, you can square root both sides. X equals plus or minus. So 12 is 4 times 3. 12 is 2 radical 3. The square root of 12 is really 2 radical 3. But since it's negative, it's 2i radical 3. 2i radical 3. Do not square root until you have the squared term by itself. So first, you need to subtract 4. 2 times the x minus 3 squared equals negative 8, negative 4 make negative 12. Still don't square root both sides. Divide by 2. X minus 3 squared equals negative 6. Okay, I have the squared term by itself. Can I finally take the square root of both sides? Yes. X minus 3 equals plus or minus. 6 cannot be factored, but since it's negative, we're going to have I radical 6. When I say factored, I mean there's no perfect squares in there. Last thing, add 3 to both sides. 3 plus or minus I radical 6. That is nasty. But if you want to check your answer, you can. I'll show you how. This is a cool trick. 3 plus I radical 6. If I tell the calculator to remember that horrible, horrible complex number is A, so store A, there's a bell, plug it in. A minus 3 squared plus 4. If I type that back in the left side, I should get negative 8. Do I get negative 8? Yeah, so I know I did it right. Awesome. Use your calculator if you got one. Vertex form of a quadratic is a times x minus a squared plus k. A still tells you whether it opens up or down, but hk is the vertex. Now this is kind of tricky because you see the minus sign and you have to realize that the equation calls for a minus sign. So the h is what you plug in. People are like, oh, you flip the sign. You're not really flipping the sign, it's just the equation has a minus sign built into it. You'll see what I mean here in a sec. So where's the vertex? Well, if you think about it in terms of translations, this x minus 3 makes it go right 3, and on the outside that makes it go up 2. So if you're thinking about how you would sketch it, you go right 3 up 2. The vertex is at 3, 2. That's why it's x minus, what do they plug in? They plugged in a positive 3. The y-intercept is not 2. When you're trying to find the y-intercept in vertex form, I never say anything about the y-intercept. You do it the same as anything else. You plug in 0 for x. 0 minus 3 squared plus 2. Negative 3 squared is 9. 9 plus 2 is 11. So when you plug in 0, you get 11. The y-intercept is 11. Here, this would go left 1 and down 6. That's a left. So negative 1, negative 6 is the vertex. And if you plug in 0 here, it's a little bit more work. Negative 2 times 1 minus 6 is negative 2 minus 6. So that's 0, comma, negative 8. When you plug in 0, you can figure out the y-intercept for any function. Plug in 0 for x, you'll find the y-intercept. Intercept form, a times x minus p, x minus q. Again, a does the same thing in all three forms. It tells you whether it opens up or down and affects the width. But p and q are the x-intercepts. It's kind of like vertex form where there's a minus sign built in. It's easiest to see it when you have an example. So the x-intercepts are when y is 0, and we have this property called the zero product property that says if I can set one factor equal to 0, 0 times anything is 0. So when does x minus 2 equal 0? We'll solve it like an equation. When x equals 2. When does x plus 4 equal 0? Solve it like an equation. When x equals negative 4. You can usually do this in your head, but the zero product property is helpful because it says if you multiply two numbers and get 0, one of them has to be 0. So how do I make this 0? 2. 2 minus 2 is 0. 0 times who cares is 0. That's one of my x-intercepts. Same thing here. Negative 4 plus 4 is 0. 0 times who cares is 0. So my two x-intercepts are at 2 and negative 4 from intercept form. All right, what if I ask you to go from standard form to vertex form and intercept form? So vertex form, you need to complete the square. So we're going to subtract 9 first. Y minus 9 plus something equals x squared plus 10x plus something. Do I still have that? Oh, come on. Work, work, work. Yes, awesome. Okay, so half of 10 is 5, x plus 5. So I know on the right side when I factor, I'm going to get x plus 5, but I got to add 25 to both sides. So add 25. 25 minus 9 is 16, so y plus 16 equals x plus 5 squared. You're factoring the right side, use the picture. Then if you want to convert it to vertex form, you need to move this 16 over, so y equals x plus 5 squared minus 16. That is vertex form, so I can tell you the vertex is left 5 down 16, negative 5, negative 16. Intercept form you need to factor. So you need to find numbers that multiply to 9 and add to 10. 1 and 9 or 3 and 3. It's 1 and 9. I'm going to split the middle. X squared plus x plus 9x plus 9. Factor by grouping. The first two terms have a GCF of x. X plus 1. Bring down the plus sign. Those have a GCF of 9. X plus 1. So intercept form is in one of my factors is shared, x plus 1, and the other terms are x plus 9. So that's intercept form. I know the x-intercepts are negative 1 and negative 9. What if I say go to standard form? So I want it to be ax squared plus bx. The trick to this is you need to make sure that you write this out. X plus 1 squared is not x squared plus 1. If you're in my pre-calc next year and you do that, I'm going to freak out. You need to write it out and you need to expand it. That is so wrong. Do not do that. Write it out, and then if you want to think of it as foiling, foil. X squared plus x, there's another bell, plus x plus 1. Combine like terms. X squared plus 2x plus 1 minus 3. Distribute the 2. 2x squared plus 4x plus 2 minus 3. Combine like terms. 2x squared plus 4x, 2 minus 3 is negative. Hey, we did it. Okay. That is standard form. You have to expand the binomial, and then you have to distribute the 2, and then you have to subtract 3. The order of operations is important. You have to follow it. For this problem, I'm going to do it the same way. I'm going to expand this out. X squared plus 4x minus 8x minus 32. I'll leave the negative 3 alone. Combine like terms. That's negative 4. Then I'll distribute the 3. Negative 3. Negative 3x squared plus 12x plus 3 times 32 is 96. So that's in standard form, converting it all. So negative 3x squared plus 12x plus 96. That's one from Vertex form and one from Intercept form. So that's pretty much all I can throw at you. Solve by factoring. So you need to set it equal to 0, subtract 80 on both sides. You could solve this one using square roots, but it says by factoring. When you factor, this looks like it's supposed to be dots, but 5 is not a perfect square and 80 is not a perfect square. So what to do? Always do GCF. Factor out of 5, x squared minus 16. Then, hey, it's dots. The square root of x squared is x. The square root of 16 is 4. So these are conjugates, x plus 4, x minus 4. Don't forget the 5. Doesn't affect anything as far as zeros go, but it's still there. That's factored. When does this factor equal 0? When x is negative 4. When does this factor equal 0? When x equals 4. Ta-da! Plus or minus 4 are your x-intercepts, or your solutions in this case. Get everything on one side. X squared minus 2x minus 8 equals 0. Find numbers that multiply to AC. 1 times negative 8 is negative 8. And add to the middle, negative 2. 1 and 8, 2 and 4, negative. 2 and negative 4. X squared plus 2x minus 4x minus 8. GCF of the first two terms is x. X plus 2 minus. GCF of those two is 4, x plus 2. My factors are x plus 2, x minus 4. When do they equal 0? When x equals negative 2 and when x equals positive 4. When it says solve, your answers better be x equals something. Get everything on one side. 3x squared, I need more room. 3x squared minus 20x. And make sure you write it in standard form. Okay, write it in standard form. Put the b term in the middle. A times c, 3 times negative 7 is negative 21. B is negative 20. So what multiplies to 21? What multiplies to negative 21? It's right there. 1 and negative 21 add to negative 20. So 3x squared plus x minus 21x minus 7. Find the GCF. X. 3x plus 1 minus GCF 7. 3x plus 1. See, that's plus 1 because if I distribute negative 21x minus 7, that's awesome. Okay, so 3x plus 1 is a shared factor, and then x minus 7 is the other factor. When do they equal 0? Well, this one's easy, when x is 7. If this trips you up, write a little mini equation. When does 3x plus 1 equal 0? Well, subtract 1. Divide by 3. Negative 1/3. X equals negative 1/3 is my other 0. We're getting close. Complex numbers? All right, complex numbers. So complex numbers all stem from the idea that the square root of negative 1 is imaginary. A negative times a negative is a positive, and a positive times a positive is a positive. So we had to make up a number that has, when it multiplies times itself, it gets a negative. And that means that I squared is negative 1. When you're simplifying, sometimes that matters. This problem, it doesn't. This is just a minus sign. So there's nothing on the outside of parentheses here. But I have to distribute the negative. So minus 4 minus I. Then I have to combine like terms. Negative 3 and negative 4 make negative 7. And 2 minus 1 is 1i. Now, your answer must be written in the form a plus bi. That is the standard form of a complex number. If you write it like, oh, it's I minus 7. I'm like, no, it's not. It's a plus bi, so you must write it in that order. This is an addition problem, so 1 plus 2i. The parentheses don't mean anything. Just combine like terms. 1 plus 1 is 2. 2 minus 3 is negative 1i, or negative I. Again, a plus bi. This one you have to expand. 5 times 2 is 10. 5 times 7 is 35i. Negative 3 times positive 2 is negative 6i, and negative 3 times positive 7 is negative 21i squared. This is what I was talking about before. I squared is negative 1. So negative 21 times negative 1 is positive 21. This is a positive 21. Positive 21 plus 10 is 31, and 35 minus 6 is 29i. So 31 plus 29i is your answer in standard form. Home stretch. Standard form means we cannot have a irrational number or an imaginary number in the denominator. We have to rationalize it. So give him a buddy. Multiply by I in the top and the bottom. The reason this helps you, in the bottom you have 2i squared, which is, I squared is negative 1 times 2, negative 2. In the top, you have to distribute 3i plus 4i squared. That is negative 4. So negative 4 plus 3i. That is not standard form. Distribute the negative 1/2. Negative divided by negative is positive 2. Positive divided by negative is negative 3 over 2i. 2 minus 3/2 I is the only acceptable answer. If you have a binomial in the denominator, you might have to multiply by the conjugate. So you change that middle sign for a very good reason. Let's focus on the denominator right now. If I expand out the denominator, 2 times 2 is 4. That's not very good. 2 times 2 is 4. Plus 2i minus 2i minus I is I squared. Okay, so what? Well, those cancel out. Sweet. Negative I squared is minus negative 1. That's plus 1. So 4 plus 1 in the bottom is 5. Cool. Still have to deal with the top. In the top, I have 2 times 2, 4, plus 2i, plus 2i, plus I squared. Okay? So these don't cancel out. Those are like terms. That's 4i. But again, this is negative 1. So 4 minus 1. 4 minus 1 is 3 plus 4i all over 5. Still not done. Not in standard form. Distribute the 1/5. 3 over 5 plus 4 over 5i. Are we done? We're done. Good luck on your midterm. Obviously, you can watch this video, pause it, slow motion it, do what you need to do. But good luck, and that's the first quarter done, guys.